Please like and share this video so that maximum number of engineers may be benefited. Also, please subscribe to YouTube channel to receive the updates about the future events and to receive notification when we go live. If you want to receive regular updates related to live technical discussions, online courses, etc. through email, then you may register at a link showed on the screen.
Hello, very good afternoon to all of you, and welcome to this unique live technical discussion series. So today we are going to have talk on different grades of reinforcement and structural steel. Of course, it is a very vast area, so that we are trying to attempt an overview in this session, and definitely we'll be having many more interesting session coming forward on this interesting topic. Okay, so welcome Piyush and very good afternoon. So through the registration form, we have received almost 100 plus interesting questions related to, let's say, the reinforcement and the structural steel. So few of them we will attempt to address in today's session. Okay, and you can mention, let's say, from which location you are participating into the live chat. So right now this broadcast is live on YouTube, Facebook, and LinkedIn, and you all will be able to interact with us through the live chat. Okay. So whenever we talk about the engineering, see, there are multiple stages in the engineering. Yes, very good afternoon, Abhishek. So pre-feasibility is the first stage, we can say, wherein just go no go decision is being taken, and very let's say based on the fundamentals, or let's say based on quick thumb rules, the quick estimation is prepared during the, let's say, for establishing the business case, and that is called as a pre-feasibility study. Right. And after pre-feasibility study, we get into the basic engineering. So in basic engineering, generally the tender specifications may be firmed up in the, let's say, in the few projects. So that is also, I consider it as a very important stage of engineering, wherein, let's say, the different specifications for different materials may be firmed up in the basic engineering. And thereafter we get into the detailed engineering. And in the detail engineering, as we know, there are multiple stages, like preparation of structural system, performing computer analysis, performing design of structures, preparation of drawings, etc. But out of all of these, the one of the important stage is selection of the appropriate material. That is very important. So let's say we have used sophisticated software, or let's say we have performed, or rather we have gone through, let's say, very rigorous process of analysis and design. But let's say the selection of material is not proper, then the whole intention, or let's say the whole aim, or let's say the whole purpose of the design will not be achieved. So this is one of the area, according to me, wherein the appropriate material to be selected. So in today's talk, we are going to talk about one of the important material for the construction of the structure, which is either structural steel in case of steel structures, or let's say reinforcement in case of RCC. So generally we tend to get or rather we tend to take the decisions based on the Indian standard codal provisions. But generally we may not, means, as a structural engineer, we may not have adequate background of, let's say, the metallurgical part of this material. So that's why we decided that let's have a talk on this important area, wherein we get into, let's say, in the insight of this material from the perspective of metallurgical science. Okay, so with these thought, we approached Dr. Jayanta Kumar Saha, and promptly he said that he will be very much interested in taking up this topic. So very soon he will be joining with us. So he is right now a director at SJ Engineers and Consultants, and he's visiting professor at Calcutta University. He's having overall 38 years of experience, and he is a BE into the metallurgical and material engineering. And he also worked with the Instack for, I think, more than 2 decades. Okay, so let's invite Dr. Jayanta Kumar Saha for this very interesting discussion related to different kind of reinforcements and structural steel. So very warm welcome, Dr. Jayanta Kumar Saha, in
Yeah,
this
thank you.
unique live technical discussion series. Yeah, yeah, yeah. So So I was just talking to the audience that as a structural engineer, always we struggle from the metallurgical part of the material. So of course there are certain guidelines given in the Indian standard codes. So always we tend to get, or we tend to take decisions only based on the numbers, but we really do not understand the core part from the metallurgical part. Let's say whenever we have to choose the right material for our project. Okay, so so still people are joining right now from different parts of the country. Okay, so what we will be doing essentially, we will be having short presentation from you, right, Dr. Jayanta Kumar?
Yes, yes,
Yeah,
yes.
yeah, yeah. So we'll be having short presentation, and thereafter we will be taking few questions which are coming through the live chat, and also we have collected few questions which have come through the registration form. Okay. Okay, so before we start, I'll request Dr. Jayanta Kumar Saha to introduce himself and then just quickly tell us about his journey into his professional career before we get into a real discussion related to reinforcement and structural steel. Yeah,
Is it really required?
yeah, yeah. Just for benefit of audience, right? That's all.
Yeah. Good afternoon, my
Yeah.
dear participants and
Mm,
esteemed professionals. Uh, Myself, Joyanto Shah. I have been in this manufacturing industry since my graduation in metallurgical engineering. Started my career from Hindustan Aeronautics, and then I was with CSIR, one of the lab in workshops activity, and then before switching over to Institute for Steel Development, I was with the Philips India with the manufacturing base. And during this journey, I was always with the the practicing engineers to learn a lot of things, starting from shop floor to the field. And that's how I completed my post graduation from IIT Madras. Subsequently, I did my PhD also from corrosion engineering on the steel structures. So that's how. And during my last stint in Instack, I've been with breathing with the steel, which is very dear to my heart. Starting from the steel as a generic material to steel as a most important material for the construction industry. And my most comfort areas are the welding fabrication of the steel structures, along with corrosion protections and fire protections. So with this background, right now I am the director of this company of SJ Engineers and Consultant, and for last I think near about 7 8 years, I have been attached to the engineering colleges to teach the applied engineering part, mostly what is not taught in the academics and what is not written in the books. So those are the things, as like you only, whatever I have learned in the process with my professional engagement, those things I used to share with the students. So now the topic what Mr. Bhabin has mentioned, uh, so without saying anything, it's one of the very important, and that too with this when the economy is open, all the commodities are being traded different places. So we should be very smart enough to choose the right kind of material, but at the same time, it has to be cost effective. That is
Yes.
a challenge for the engineers. And I believe, being a civil engineering fraternity, most of you who are attending this program, it is a great profession, though I am not from this civil engineering, but I work with the civil engineering people. But in this great profession, there are great risks involved with your professions, not like other engineering streams.
Yes.
Because today, what you are developing, what you are bringing in, that is to be displayed to the society. If anything goes wrong, that thing has to be, fixed. Who is behind this, making these structures collapsed? So thereby, one side you are very much proud being a civil engineer, but the responsibility lies more than that. So that this type of privilege, I don't think any other discipline has got, because you are really creating something, starting from a house to the infrastructure to the anything you would make in the industrial structures or in society, whatever we make, it is basically the civil structures. So thereby it is paramount important that we should know about. So today, in this short discussion, what I am just going to tell you about this, how to select the right kind of structural steel. Now the definition of the structural steel, it is something like that: the material which are being used for the construction activity. That's what sometimes it is called the plain carbon steel, mild steel, or maybe the construction grades of steel. Very often we get a confusion. I am using nuts and bolts, some mild steel material or plain carbon steel, en 1020, but at the same time when I'm talking about the structural grades, people are talking about is 2062. So thereby, when it is very much specifically used for the construction activity, the special designation is given as a structural grades of material. Now, these structural grades of materials can be used for a steel intensive structures where 100% steel is used, maybe a hybrid structures like composite structures or the blend of the steel as well as the RCC, or maybe a place, it may be a RCC structures. There again, we can use the structural grades of material. Name is different, we call it the reinforcement bar as on date, because in earlier it was a plain bar. The today's our code also talks about the 1786 is a bar or rod along with the reinforcement one. So that means you can also use the normal bar, or you can use also reinforced bar like CTT or TMT. Now I request Mr. Babin to just display my the first one, and I'll just go one by one from this. Now, in between, if you have any questions, kindly just put it in the chat box, so that if time permits, definitely whatever near about 100 and odd questions you have received through the registration, and still there are a lot of questions are coming, that indicates that this subject is really, there are areas we need to learn about this. So we have a lot of things unexplored, unknown, but at the same time, I'll just try to address all those issues depending on the time availability. Now, the structures of the small presentation, it is just to sensitized, because I understand there are a lot of things in the material engineering and science we all have studied in different formats, starting from class 12, syllabus. There is a small chapter is the metallurgy. There we used to learn the iron making, then sodium, potassium extraction, all those things, aluminium extraction, if you can remember. So apart from that, in your engineering, also you have learned engineering materials. There are also little bit you have learned. Now with this, if you see the structural material definition already I mentioned, and if you see the generic application of the steel structures, it starts from 1780. There the heavy structures made of a cast iron was made, I will be showing you some of the structures which are really made with the cast iron, and still it is surviving with its full strength. And then the wrought iron products are also developed parallelly. And then finally, we are talking about the steel period, where most of the structures are made with the different grades of the structural steel that we will discuss. Now, this is a very obvious fact. When we are going for any structures, there are four important things. We ask the architect, kindly give me a design. It stands out with the existing structures. So we talk about the aesthetics. The Burj Khalifa, that building, anyone can like that. If you see before that, the structures which was the most tallest structure, that was equally elegant, but the feature wise the latest one may be more. So thereby the continuous thrust is there, making the structures aesthetically very pleasant. That's why steel is one of the option, because you can make it in different forms, different shapes, and in the different dimensions you can have this. And the second one is the cost effectiveness, definitely, otherwise the material will not be the sold. And at the same time, the moment I said both, then the third two dimensions, third and fourth, are the safety requirements and the durability. That is the maintenance free life of the structures. So all the four here, most important aspects, all the four cases is the material. If you see, the common is the material. If the material is good, if you are giving a good durable coating on the material, so durability is high. In the safety requirement, if the welding of the weld material is good, then the structure has got a more safety. If the fireproofing material is good, then the safety of the structure is also good. So like this, the common thing is the material part. And if you see this historically, starting from 1779, how the structures are looking, it was a very bulky, and aesthetically it was not elegant. Starting from that period of time, and you can see in 1974, Sears Tower, now it is called Wills Tower in USA, in Chicago, that is made with the medium strength structural grades of steel, 250 and 345. Now think about in India, we are still following maximum 250, and there are limited cases where people are going for 410 grades of the structural steel. So the structures, what I'm showing it to you, the reason behind, the higher the grades of the structural steel you use, the performance of the structures, the material consumption of the structures will be the less. So that there is again a chicken and egg story. These high grades of materials are not available off the shelf with the steel manufacturers. That's what I am not using. But other side, the steel makers say that if you ask me, give me a lead time, I'll make steel up to 650 MPa values as per 2062. Think about the 2062, there are grades we'll discuss, but only we are still at the entry level. We are operating most of the design activities in the operating entry level of materials as per the codal provisions. Now the structural steel classification, I have made it in the two. One is the plain carbon and the alloy steel. In the plain carbon, it starts from the carbon level up to 0.25 and the 2.5 to 0.65. So here again, mostly the reinforcement bars are falling. 0.3 is a higher range of carbon, and other structural steels are mostly within 0.25. And other structural grades of steel, when we talk about the alloy steel, if it is more than 5%, here we call like HSLA, high strength low alloy, fire resistance steel, weathering steel. All these are coming under low alloy steel. And the medium alloy steel is like stainless steel. Maybe that duplex grades that we will discuss subsequently, little bit on that. And I think there are few questions also on both the topics. Now, at the beginning, when we are making a tender document, what as a owner or what as a professional we should look for? The first thing is the quality considerations of the material. So the architect has given you the material attributes. These are the materials. The UTS value should be this. The hardness should be this. Bendability property, or if it is a dynamic structures, it should be the fatigue loading or the fatigue life of this. Then weldability aspects, all those things are defined. Now, apart from that, as a as my friend Mr. Bhavin has already told, that after the pre-feasibility, we go for the basic engineering. And in that basic engineering, there are certain questions you have to ask. These are the questions I have just put it here. The first one is the chemical compositions. We have to find out from the major manufacturers. Nowadays, these things are available in the website. These grades having what is the chemical compositions. The two important materials here is the important issues, the residual impurities. The quantity should be the less, gaseous content should be less, like oxygen or nitrogen, and at the same time the trace elements. Then the homogeneity means the micro and macro segregations. These are the some of the attributes you can get from the material eyes closed when you are buying this product from a reputed make, or the technology has got a very proven status on that. Okay, so this is the first one you have to mention, or you have to remember. The other things are, I have just mentioned that one. If you are interested, you can get this copy of this presentation material. This can also be shared with you. And the last, not the least, is a steel cleanness impurities, like impurities like sulfur, phosphorus, oxygen, hydrogen, and nitrogen. These things should be less. The the quantity of this material will decide the steel is the clean or it is the unclean steel is the defective steel. So thereby, the more you want the cleanness of the material or the steel, structural steel, you have to pay more money for that. So that is the thumb rule. And then other trace elements, there should be minimum, so that you get the steel will have, these are the properties like formability, impact strength, weldability, fatigue life, hardenability, dimensional accuracy, and machinability. All these things should be there. Now, coming to the quality issues, when I said the first one you have understood, the second part, I have just put a very consolidated snapshot. There you can see I have written two things: world scenario and Indian scenario. Just look at, there are various ways you can make a steel. That is we call it the BOF, basic oxygen furnace process, and then the electric arc furnace, and that there are some other hybrid process which are not very popular, one of its kind somewhere in the globally somebody is operating. But in India, apart from the first two, you will find another type of steel making process. We call it the induction furnace. This induction furnace is a system where if you put garbage in, you will get garbage out in the form of a steel. But see, the percentage wise, it is 32%. That means if you are not selecting the proper technology from where you are buying the steel, then you will definitely land up with the poor quality of steel, because from the outside steel looks the same. The steel made from the best quality manufacturers, and you are buying a steel from the worst manufacturer. Outside appearance wise, both the steel will look alike. It is only you can be you have to find out from where you are purchasing. So this is the technology part I am just explaining. So this is the second issue you have to find. This is some of the photographs what I have. And if at all somebody is having induction furnace process, there you have to ask for the ladle refining furnace. That is another system, add-on system. That is a costly process, but very often people are only going for the manufacturing of the steel through the induction furnace route. So we should be very careful about induction furnace route before selecting any material. Think about the integrated steel plants. I am just telling, the buy the steel from where they have a control of raw material, starting from this raw material to the end product, where you are getting the slabs or the final products. So that means the entire quality, through various stages, the material has got a control, and steel has to have very good quality as required as per the IS standard. So next one, you will find this is how, the moment you are getting the slabs or the blooms or billets, those things are rolled. There is a question on the why this rolling is required. Unless otherwise you get it rolled, this is through the rolling process, you are basically trying to break the microstructures in a more finer form, and thereby you are giving more strength and other properties in the material. So, and this is a one process, one type of heat treatment also in the process also coming. So there you can see these are the basic structural materials starting from plates. Then you can get various type of structurals like beam, column, I sections, and angles. There is another quality issues are coming. I have deliberately put there are two terms. One is the semi-finished, another is a final product. Semi-finished, these are the product called semi-finished, bloom, billets, and slabs. In the earlier slide, I have showed you up to what stage the material is cast. And these casting materials has to be as per IS standard 2830 or 2831. The better the material, like IS 2062 structural grades or maybe IS 1786, the reinforcement bars, it has to be rolled out from bloom or billets of IS 2830, not 2831. So this is basically the difference. So you have to again find out from the tender document, or you have to mention in the tender document the material has to be rolled from the semi-finished of IS 2830. It should not be from IS 2831, because IS 31 is the low grades of the structural steel, and for the proper or general structural grades it has to be rolled from 2830. So that I have given in the definition here. IS, kindly note it down, 2830. And then the material, after coming out from this, as a semi-finished product, then you need to have a control over the microstructures that you have done through the melting process. Then comes how we are further increasing the strength or the improving the property of the steel in terms of the yield strength or in terms of any other property as required for the product. There are two other processes. We call it the heat treatment. That means heating and cooling the steel through this process. Like structural steel, normally we don't do heat treatment like tool steel separately. It is through the rolling process the heat treatment is done. For the reinforcement bar, when you are taking out the bar from the mill, the heat treatment is done through the quench and temper process. We call it sometimes we call it the QST bar. So this is how it is a heat treatment process. And from that heat treatment, ultimately, and the deformation by various type of rolling, or the hot rolling or the cold rolling, you get this type of microstructures. And there is a very complicated chemistry behind it, and that is the job of a metallurgist. So I will just only mention here that depending on our requirement, we get various type of low carbon steel, where you get 100% ferrite, you get 100% pearlite, and then the combination of all. And these basically attributes to the specific property of the material. So you can see in the microscopic level how it looks. The outside steel look the same, but the moment the structures are different, and these structures are getting through various processes. This is again a typical rolling technology where the slab to and then final, as I have mentioned in the earlier slides, various type of microstructures we are attending, and there are various type of rolling process. Now this rolling process, you will again in the tender document you have to mention that structural steel as per 2062 of 250 MPa value, and then you have to write whether you want grade A, grade B0, or grade BR, or you want grade C. You start from A to C, then the quality of the weldability quality increases. Then if you are going for the BR, that is the impact value is the room temperature. Suppose you want to use a steel in the place like Leh, then you need to have a sub-zero temperature application. So impact value of the steel has to be minus 70 or minus 80. So thereby you have to go for the third category, that is a less than 0 degree. So that's how, and at the same time, the quality of the steel you have to define with this heat treatment process that we write as rolled, normalized roll, thermomechanically controlled roll. So there are various processes. The moment you open the catalog of the major manufacturers, steel manufacturers, you will find all those things are written in the at the side of this product. So you have to be again conversant with that, the what heat treatment procedure I have to follow for my product. So this is how through this rolling technology you get the microstructural changes and orientation. So just to make you more understand what I said in the last two slides. Now you see, for structural grades as per IS 2062, very interesting fact here. You see, starting from 250, 350, 450 and 500, 550, you see the chemical compositions are not, variation of the chemical compositions are not much. You can see the carbon is 0.22 to 0.20 in one places, manganese 0.50 to 0.65, sulfur phosphorus level is almost same. These are all impurities. But with this, you find the carbon equivalent is starting from 0.39 to 0.54. So the lower the carbon equivalent, the better the weldability. So these are the materials where, but these are all weldable material. And then you can see the percentage elongation. With the higher grades of steel, you have a lower elongation percentage. But the chemical compositions are not varying much. Then what is the process? The process through this, as in the earlier presentation I made, through the heat treatment process, and you get all those things, the TMCP or NR, FN, all those things what I mentioned. Through that, we increase the strength of the material, and this consumes a lot of time. That's what the cost of the 250 grades of structural steel is much lower in compared to 450 grades. But if you see the ingredients wide, it is not much, but it is a time which consumes with this type of process that makes the product more costlier with respect to the lower grades of the steel. Now the structural steel, in portfolio, if you see that, this is the steel has got the two definitions, the flat products and the long products. And in the structural construction areas where you get this is the area, and other area is the earthquake resistant steel or the special grades of steel. Those are coming under structural grades of steel. So I will not read into this. You all know. I'm just to make you understand the definitions, and these are the structural sections, and there are some of the applications. This is again some of the photographs of that, how this product look like. Now about the plain carbon steel, we learned little bit what are the basic requirements, how to choose, how these different types of grades of materials are developed, and in a tender document what we should write. Now you have a challenging situation where you can see that normal carbon plain carbon steel will not serve the purpose. Even on the coating on the plain carbon steel, it is not lasting. I am talking about galvanized. I am talking about in terms of the various type of organic coating. What is way out? The option is you have to go for the medium alloy steel, that is called the stainless steel. Now the stainless steel, because the definition is it has got certain amount of alloying elements like chromium or nickel. That's why it becomes a rustless. In other case, we get a rust layer on the top, and continuously that rusting is getting increased, and thereby you lose the steel. But in case of the stainless steel, there is a rust layer at the top, but this top layer we call it the passive layer. That means it is not allowing further to get corroded further. But the stainless steel, when we are using as a structural material, it is not only one grade which serves all the cases, because I have mentioned here it also corrodes in the low oxygen, when the oxygen supply is very low. In the case of the marine climate, that is a chloride ions are very high in the atmosphere, or the poor circulating environments, or the area is very stuffy, there you get the stainless steel also starts corroding. So that then it makes a challenging things. What type of stainless steel should I use? In normal case, we know the austenitic stainless steel, ferritic, martensitic, but there are various applications. But for the construction activities, you can see that these are the stainless steels are used, and after that, this is the area where the stainless steel is used. This is a composite type of structures. There you can see there are two grades. One is the austenitic, other is the duplex. And nowadays the duplex stainless steels are very popular, and these are the series. In duplex stainless steel, we have 6603 code earlier, and then we have stainless steel duplex reinforcement bar codes also. I have mentioned. I'll be mentioning that code number also. And here, the reason behind, apart from the corrosion issues or maybe the service condition, other important is the stainless steel duplex grade can replace the normal structural grades with the half of the material, or maybe the less than that. Because the strength class you can see up to 600 when we are using only 250 or 300 grades. But the stainless steel series itself is a higher grades. So you get a now that is the second options, the plain carbon steel, and then you can go for the alloy steel, or you can go for the low alloy steel, as I mentioned, weathering steel or fire resistant steel or earthquake resistant steel. So depending on its application. Now, coming to whatever I said, then the question automatically comes to our mind: how do I find out? You said that go to the good technology, go for the good product. How do I find out from the market when I'm seeing everyone is showing their brand to the televisions? We are making the best quality of the TMT bar, earthquake resistance, structure will not collapse. How do I find out whether they are really good or not? So the India, Government of India, the Ministry of Steel, they have started a campaign called the branding of the quality steel. So like, whatever logos you are seeing for the veg, non-veg item or the seal mark. So the steel has also got ISI mark. Now go to the BIS site. You write down, there is a database. You write down the TMT bar, IS 1786, diameter 10, grade is 500 or 550D. Who are the manufacturers? It gives a list, because it is not only the company who makes only one type of rebar. From the database, you will find out the fleet of all the products, like 550 grade. Suppose the manufacturer makes starting from 10 millimeter to 25 millimeter, you will get all the incremental values whether they have got a license or not. So that is one that gives you more confidence. The product has got certain confident, inbuilt quality assurance, because BIS has got the surveillance on the products. Next, we will go to the some of the branded products, as I mentioned. So the first part, it is basically the structural steel grades, and the second part is the reinforcement part. Here I have mentioned highlighting four. The code numbers are given. Some of us, we may not be knowing that for the non-critical application, you should not use the 2062 grades of steel, because the steel is costly. There you will find another code, that is 15911, that is used for ordinary quality or structural steel. That means suppose you want to make a small material or any small unit in a structure which doesn't carry much of load. So there you can use this type of material as per this code 15911. That means this code is not very old one. So it has been again reaffirmed in 2020 or 21. So this code, starting from 165 MPa value of steel to it has gone up to 250. There are 3 or 4 grades are there. So why to unnecessary waste when your requirement serves with the 165 MPa value of steel? Then other two type of steel very often we are neglecting, that is the weathering steel, that is 11587. This weathering steel doesn't require any type of coating, provided you know the proper uses and the environment where the structure is will be available or situated. It gets weathered with the environmental conditions But the basic requirement, there should be wet and dry cycle. That means there will be rainy season, there will be the summer, there will be the winter, and within 18 months, the steel will have a very thick layer of coating from the environment, reacting with the environment, and we call it the weathering steel. So that steel, the moment you get a weathered coating on that steel, the steel life will be almost life. There is no life for that. You get, there is no maintenance for that rather. So this is weathering steel. There are a lot of only thing that there is a cost involved on that, and but the maintenance cost is almost zero. Other one is the fire resistant steel in India. Only Steel Authority of India has got a capability to make fire resistant steel. But only thing, the because of the exorbitant high cost, this steel is not very popular in our country. But if you search in the internet, you will find there are a lot of buildings in Japan and USA and Germany. They are coming out with fire resistant steel. So this is also a popular one elsewhere, but not in our country. Then you can see for high reinforcement part, this is I'm not discussing right now. There are certain quotes I have just mentioned here, important quotes. This already I have discussed 2062. There are 27 grades. I said there is it is not only I am just mentioning the IS 2062. Answer is no. So IS 2062, it has got 27 grades starting from 250 to 650. If you add up all those things, it comes 27 grades. So A, BR, B0, C in some cases, all three, some cases only two, A and BR. So impact value at 0 degree, we are not able to develop so far. So that's what B0 is not there, or minus low temperature, it is not developed till. So that's what you will find the UTS value starting from 410 to 780. But the moment you go down from 300 below, so not much applications, and the quality of the steel or the cleanness of the steel is decided based on the deoxidation of the steel. Now we'll stop here on this structural steel discussion part. So there are four take on from this. Number one, as when we are making the tender document, we should be very careful about what is my requirement in terms of the properties or the performance of the steel. I should be very clear about that. The second one, the what's grade I should look for, and the source of the grade from where I'm getting it, and then cross-checking with the BIS site whether this product is licensed to BIS or not. So all those things will make you the tender document foolproof, so that at the beginning you will find this material what you are choosing, it is correct. So at the end you should not repent for that. Now with this, we go to the second part of that. It is a reinforcement bar. As Mr. Bhavin already said that at the beginning, that reinforcement bar, it is again an important issue. The in any developed nation, there you will find the RCC structures has taken a backseat. Steel-based construction is taking leading in that construction area. But in our country, it is a long way to go for the steel intensive construction, unless otherwise it is a requirement. So people are not going for the steel based construction. So thereby the importance of the reinforcement bar for the RCC structures, it will be for coming years, it will be still more. So the requirement of the reinforcement bars is, first thing, we should always go for the high strength grades. We all know as per IS 1786, it starts from 415. Then you have a 415, normal grades. Then you have a seismic resistant grade, we call it a S. And then you have a ductile grade, we call it the D. So 415 normal, 415 S, and 415 D. Or D and then S. Same way you go, next step is a 500, then 550, then you have a 600 grades. And there are, activities are going on to make up to 700 grades. Some 2 or 3 major manufacturers, they are in a process of developing that 700 grades of TMT bars. So these are the requirements for the TMT bar when you are selecting for your tender document, that it should have a very high strength depending on the design parameters. I'm talking about in terms of the tensile strength. Then the bond strength has to be good. In the code it is mentioned what should be the bond strength, and then the higher elongation, starting from the normal grade to the ductile grade to seismic grade, elongation value increases. And other way, you will find if you are seeing the higher the grades, the elongation also coming down. That means 415 elongation is higher in normal case, 500 elongation is still lower, and 600 elongation is still lower. That means you have to find out that what is my the structural requirement, and based on that I have to select the right type of reinforcement bar. Because like structural steel 27 grades, here also you have at least 25 grades are there, so you have to select the right one. Then definitely in some cases you have to have some welding issues. Higher diameter normally you have a splicing facilities, but the lower diameter you have to go for lap joints, so the weldability also has to be taken care. Then the bendability, rebendability, those things are also important. For the stirrups, there is a question on that why you should go for the 415 grades, because of the better elongation. So you can bend it very easily. So that is the reason. One question I find that someone has asked me why the for the stirrups 415 grades is used. Then in the concrete solution, in the concrete RCC, most in normal case when you are cast structures, the alkalinity or the pH value of the concrete is normally it will be in the range of 13 to 15. Now with the time, if it falls below to 7, then it becomes the acidic media, and then with this acidic media, this rebar will be attacked by the acid, and it will be starting when the corrosion will start. So that's what, depending on the environment, again you have to select what type of reinforcement bar. Should I only use the plain reinforcement bar? Because you have a choice. Now plain reinforcement bar, you have a choice. Corrosion resistance reinforcement bar, you have a galvanized reinforcement bar, you have a stainless steel reinforcement bar, you have a what is that fiber reinforced reinforcement bar, or the carbon reinforced reinforcement bar, that is the non-metallic reinforcement bar. So nowadays these are the issues, and there are a lot of conflicts in our mind that which one is the best. So again, unless otherwise you have a little knowledge about the subject, it is very difficult to select the right kind of reinforcement bar. Now this is a I made some survey some few years back, drawing some reinforcement bar from the various marketplaces in India, and then we analyze this one. So these TMT bars, as on date, there are 50 TMT manufacturers in India, 50 to 55 TMT bar manufacturers in India. They make under the license. The remaining, but if you see the TMT bar manufacturers in India, it may be more than 200 or so. That means the remaining, they have their own technology. What are this technology? That means in the name of quench and temper, that is a very high speed line. That line will be few 100 meters of length of the bed, where the rebar is moving at a very high speed with the water quench through that, so that you get two different microstructures outside the hard structures. We call it the martensite, and inside the core is a softer grade, the pearlite ferrite. So that instead of that, they are putting in a bar in a tank, and you get outside the look is same. But the moment when you take the cross section, edge it, you will find the annular ring of the outside, which provides protection from the corrosion, that is minimal. So thereby the TMT will, that time the TMT bar will have the more problem. So these are some of the TMT bars I have listed. These are the analysis, the outcome of this analysis, the bar per running meter, because you are, when you are designing a structures, you are taking the weight of the reinforcement bar. There the unit length is underweight. The defective geometry means the bond strength is comes through the geometry of the ribs. If the reefs are defective, if the height is less, then you don't get the proper bonding with the concrete. The rolling defects, twisting defects, wrong chemistry, then already mentioned the coils in the tank, then very low carbon. The carbon has to be more than 0.25. There you will find carbon is very low, because carbon means the hardness. And then hot twisted CTD bar. CTD bar is normally cold twisted. So in terms of cold twisted, they make it a hot condition because it requires less energy. That's how it look alike the CTD bar. So this type of, and another parallel industry is going on from the ship breakage in Gujarat. So I had been to this place as a government of India's team to see the place in the Alang in Gujarat. There you will find this type of global discarded ships are coming to this port and then getting dismantled, and from that you get this type of pencil ingots. So this is assorted material, and this material charging through the induction furnace sometime, or directly rolling various shapes you can make, and those things are available in the form of the reinforcement bar or the small structurals or small plates. Those are sold in the market. So thereby this type of material, if you are selecting, this will be very dangerous for the structures. So the structures will not give the proper performance as desired. This is the 2830. I told you, the for the general structural purpose this is used, and this is the low tensile. This is the feed material for both the structural steel for 1786 and 2062. This is the grade of material as a feed material. So normally in the tender document, the good tender document, it also mentions the TMT bar or 2062 has to be rolled from the billet of IS 2830. Kindly provide the billet test certificate. The MTC has to be provided with that. That means the moment you are seeing, you will find this billet has been taken from Steel Authority, or billet has been taken from JSW or JSPL. All these people, they sell it to the open market, because for the rolling of this material for subsequent steel products manufacturing. So this is very important. The first one, 2830. So in summary, I should say, when you are selecting the reinforcement bar, these are the very important things. The TMT technology, there are Temcore, or there are so many technologies are there. Uh, and you have to find out with whom they have a license. You can check also the license. From the BIS, you have to find out the grades and the diameter, whether this is a licensee of BIS. And the test the TMT bar at site. There are various quick tests are available. You just put some acid on the top of that acid solution. You can find that outside rim is uniform or not. If it is put in the tank, you will be able to see that rebar is not good one. And the elongation range has to be in the tune of 14 to 18% at least for the good structures. And nowadays nobody is using 415 grades. I was talking about that, at the field side, you can check this type of, take a piece and the top, that is a solutions available in the market. You apply these solutions and you will be able to see the uniform annular ring. That means that this product is good. This is the reefs are also good. When the product is not good, all those things you will be able to find out from the field. Now there are certain, you have selected good rebar, good technology, good branded rebar, but at the same time, at the construction site, if you are keeping it like this, you are inviting further problem to a good one, because you are getting not only the rust is good, but you invite corrosion in that. I will just mention what is the difference between rust and corrosion. And then you, in the good construction site, this is the standard practice. They will put some locks, and then the top of the locks you keep it the bars, and the end is normally protected, so that any water coming falling on that, it will be draining out from the site. So that makes the river good. So there are cases I come across, the river at the site is rusted, so they are asking the river has to be rejected, because this we cannot put in the RCC. But for your understanding, the rusting of rebar is good. Rusting means at the top layer, you will find some very reddish color powder. If you touch with the finger, you will find the reddish color powder, and it is called the rust. Now, this rust is basically helping for the adhesion with the concrete. In Indian code also, there is a clause added. It indicates rust as a phenomenon on rebar and not a cause of concern. Rust, seams, surface irregularities, or mill scale shall not be cause for rejection. There are many cases the rebar due to the rust it was rejected at the site. So in our code, like Singapore has started, they have done a lot of work on this. In the Singapore code, civil engineering code, they have specifically mentioned the rusting has to be done before you put that rebar into the system, because that makes better bonding with the. When the rusting is severe, you add other ingredients so that it starts spitting on that, then it becomes a corrosion. So the corroded steel is not allowed, because that is the area where you get some sort of the electrolyte entrapped into the system. The moment it goes into the concrete, that electrolyte will start acting on that, and the rebar will get corroded faster. So thereby, it is a very clear definitions, the rusting and corrosion. So another one or two slides, then we will take on the questions. So like steel structures, the protection durability is depending with respect to the environment where it is. That means, suppose I want to put a structures in Rajasthan in a hot, humid climate, or I want to put a structures in a place like Cherrapunji, or a place like Mandapam, the highest recorded temperature in India, or maybe in Cherrapunji, the highest rainfall area. Definitely, the structures protection has to be different. There is a logic for that, and there are a lot of data to support it, and then you can apply those things, and you can forget the structures free from maintenance for 5 years to 25 years of life, depending on the severity of the corrosion. The same way, the rebar also, when rebars are used in a concrete, it is not only the concrete it envelops, not giving a protection to the rebar, because the concrete is always a porous structures. Now, this porosity, through this porosity, continuously it starts breathing carbon dioxide, it makes carbonic acid, or it breathes the chloride ions, it makes hydrochloric acid or sulfur dioxide. From the fossil fuel, it makes sulfuric acid. So all these acidic component will slowly go in, and it will touch the rebar, and then the life of the rebar it starts coming down. So thereby, there are various climatic conditions. You have to select the normal TMT or corrosion resistance TMT, or the various type of coated TMT bars, so that this type of uncertainty or this type of futuristic planning you can have. Because today your structures is there in the urban area, so maybe 50 years down the line you will find that area becomes a very populated area. There are a lot of emission will be there, a lot of pollution will be there. Then the structures also will start breathing this type of gases, and the structures will be vulnerable for the basically vulnerable. The structure's life will be coming down. So this is my concluding statement. The information on the steel metallurgy little bit is very much required as a professional, because metallurgical engineering is no longer the baby of metallurgists. So it is basically a starting point for the civil engineers, for the mechanical engineers, for the chemical engineers, even for the architects. So thereby you need to know a little bit of metallurgy when you are dealing with the materials. Then the different type of structural materials are available, starting from the plates to reinforcement bar, various type of structural grades. And I have mentioned the codes. The code of practice is IS 800, then IS 802, 808. And then selection of the steel with respect to the quality is important, and structural steel is having challenges too in terms of the corrosions and the fireproofing or seismic applications. And the durability of the steel structures to be considered always, because unless otherwise it is called for. Okay, So now, Mr. Bhavin, we can take on some questions.
Yes, sure. Excellent presentation. Yeah, great. And you have touched upon a few very important points which were generally not being discussed, yeah, in the practice. Yeah. So let's take a few questions now. Okay, Abhishek Singh just asked during your presentation that primary and secondary steel. So is it dependent on making process?
See, I do not believe in the primary and secondary. It was a very age-old concept. We call it the primary or integrated steel plants because traditionally they own the mines, those who come first. So they have iron mines, they have coal mines, and the limestone or dolomite. So they start from the making iron and then convert it to electric furnace, making it to steel. But when a person is starting a business, some 20 years, you know, uh, 20 years, maybe 20 years back, that time there is no owner for this coal mines or iron mines. They don't get anything. So what they have to, how they have to do the business, they have to take either they take booms or billets from the major manufacturers, and they have more investment on the technology part for the steel making. Suppose I get this raw material, or I have a very good system of electric furnace followed by LRF and this vacuum degassing technique, and I make very sophisticated alloy steels, taking the feed material from a good source. The quality wise, the integrated steel plant or the secondary steel plants who has got a control over starting from the feed material for the steel making vessel to the finished product. If the finished product attributes or both the cases are the same, then the steel quality issues should not be there. But if someone is bifurcating or missing some stages which is requirement for the making good quality steel, then that is the issue. Okay, so making process, to answer your question, yes, it is very much dependent, or it is a function of the steel making and the technology issues also.
Yes. Yeah, one more question that kindly clarify regarding low carbon and steel manufacturing using recycled steel, whether it impacts quality of steel.
See, the low carbon steel means any steel which has got point less than 0.25% of carbon. We call it the low carbon steel. So the low carbon can be 0.01 to 0.25. So there are issues where you have very extra low carbon like stainless steel. Carbon again creates a lot of problem. So in the stainless steel, you find the very low percentage of carbon within the low plain carbon steel, that range. And the steel manufacturers using recycled steel, whether it is impact the quality of the steel. Then again, I take the analogy of the first question what I said, ma'am, that is it depends on the quality of the technology or the establishment you are following. Now, the when I am going for steel making in an electric furnace, the in electric furnace, you have to charge the recycled material in the form of a scrap. That is the mandatory requirement for the electric arc furnace process. So if I recycle the steel, provided the steel is properly, graded. Now in the electric furnace, the advantage is, irrespective of the feed material, you have a possibility, you have a chance to refine it. Through the refining, the desired chemical combustion you can bring. So thereby, whether you are charging recycled steel in the electric furnace or somebody is making virgin steel from the iron ore, it doesn't make any difference in terms of the quality, because electric furnace followed by other methods like vacuum degassing or maybe the LRF coupled with that. So other units what the major steel plants are making from the electric furnace to the finished product. So if you have that setup with a small establishment, absolutely there is no problem for that.
Yes. Okay, Abhishek is asking that we are designing the welded connections in seismic areas in case of structural steel buildings, but for RCC buildings, welding of reinforcement bars are generally discouraged, and we prefer laps and couplers. So, so can you please throw some lights on this? Like why welding
Yeah,
of reinforcement? Yeah.
yeah. I think I have mentioned in my discussion
Hmm.
that the both the lap joints and couplers, because unfortunately the couplers are not available for smaller diameters. It starts from near about, I think, 20-25 diameters and above. So in most of the metro relay construction, you will find the couplers are used. Uh, in at least in Calcutta, I'm from this place. I find especially the big piers, the in the diameters of maybe 40 or sometimes more than 30, the couplers are used. But the in the lap joint, definitely you can do. But only thing you have to, there are two important issues while doing carrying out lap joints. First thing is you have to select the right grades of, you know, electrodes. So the matching grades of electrodes you have to find from good manufacturers. Two, three good manufacturers are there. So you have to find out that one. And little bit of, preheating is very much required, because these structures are made with hybrid microstructures. That means outside is a martensite, inside it is a softer core. So when you are doing it, you are basically uh, welding outside to outside both the parts. So that is the, we call it as a mm, uh, penetration depth. So the penetration is depth is normally maximum, it may be 8 to 12%. So depending on that, that means it is not touching the softer core. So it is only within the martensite layer. So little bit of, heat treatment in the form of the flame heating is required. So there are, standard practices are available in the site. So they normally, but you should not bypass those things. At least preheating, then go for the lap joints. And the last important point is with the lapping, in the design, you have to see the concrete flow should not be disturbed, because the moment you are doing lapping one after another, think about two 20 millimeter bars you are lapped one above another. So that means in that area, the diameter becomes more or less 40 minus. So 38 or 30, 36, 37 millimeter diameter will be there. So that you have to ensure that you have a proper, passage for moving that concrete through that.
Yes.
Next.
Yeah. Next was the question like how good is welding a stainless steel plate with MS plate?
So stainless steel uh, welding nowadays, dissimilar materials welding. There are a lot of, technologies are available. So welding, it is a, again, right now I cannot tell which grade, but only thing I can say yes. Answer is yes, because the dissimilar materials are welded for various application in terms of the cost part, in terms of, in either sides the environment conditions are different, so you need to have the bimetallic condition. But this type of, in normal case, stainless steel to stainless steel welding, the type of care you have to take for the protection of the structures, it will be many times more when you are going this type of, because galvanic series wise, stainless steel is in one side and MS is other side. So if you are not able to protect this material properly, then you will find very fast state of corrosion in that area. So you have to see, but welding is possible. You have to always select the electrode which will have matching of the highest grades of the, UTS value of the material. Suppose you have a stainless steel has got 500 and MS has got 250, so you have to select the electrodes matching with the stainless steel grades.
Yes. What are the current development related to fire resistant of steel structures?
Yeah, fire resistance of steel structures. In my talk also I mentioned there is a
Hmm.
code and only one company they are in a they have a technology, and they have done a number of tests from CBRI, Roorkee, and in fact, I was instrumental for formation of this code. The code is IS, I believe, 15103, 15103, and this has been revised in 2021. Uh, there are couple of grades. Earlier it was 3 grades. Now they have made it near about 5 6 grades. Up to you can go up to 550. But the cost was it is very high because of the addition of the molybdenum and chromium. So people are going for using normal structural grades of steel, and the top of that you can go for intumescent coating. So that is a separate topic. If participants are interested, we can have that how to protect the steel structures from the fire hazards. So we in India we have a lot of test data on that, on the real life fire test data, and then what are the type of intumations coating we should apply depending on the issue called surface, what is called section factors. What is the mass of this material with respect to its periphery, and then you apply that. So those are the techniques. Is one is the by coating, another by filling with the concrete in the tube, and then age-old other methods like concrete wall, and then you have vermiculite or gypsum boards. All those are fireproofing techniques. But this is not a very fast-moving commodity in the structural as a structural material.
Can fiber reinforced concrete replace conventional RCC?
See, there are, for any activity you will find, there are certain, informations which normally perturbed everyone. I mean, what is this? We have been knowing about only the steel is the solution for RCC. How come the reinforced fibers are there? Normally, fibers are basically three types. It may be the carbon fibers, it may be the glass fibers, or it may be, polyamide types, so plastic type of material. But issue is this cannot be replaced. The cost wise as on date it may be slightly lower. In Delhi Metro, I think there are few lines they have tried, not in the full length in certain areas. They tried with this fiber reinforced this reinforcement bar. But this reinforcement bar, it is not very proven one in terms of when we see what is impact strength, number one. So it will not have the impact strength what steel can have. It will not have that much. Number two, another issue is coming is a creep. Creep is a time dependent activity with the temperature. If the temperature rises, the material also has to behave differently. But in case of the steel, it is a creep resistance material. That means with the respect to the temperature, if the temperature is today is say 25 degree in Delhi, and in the summer it is 60 degree, even in that the steel will not behave differently because with the time and the temperature. But this type of fiber material, they get permanent deformation in that. So the one is the impact, other one is the creep, and the third one is in case of earthquake. This is a very common sense. In case of earthquake, the structure has to shake. That there will be sway in the structures. So the steel has got is the only material where it has got a equal tension as well as compression. But this type of material doesn't have that. So that is another I said is a third dimension is added. So all those uncertainty you have to foresee, and then only you have to go for that. So in my understanding, for critical structures, structures of public interest, definitely it is not. For your own structures, you can try with that. A one-story building, two-story building, nothing will happen.
Yeah. Yeah, Professor Mainak Ghoshal is telling India loses around 5 to 7% of its GDP per year, let's say, due to corrosion. Carbon nanotubes are very efficient in resisting corrosion. So I mean to say, at what steel production stage CNTs may be added?
See, this carbon nanotubes, this is a lot of research is going on. So this is again this application wise, as you said, that colossal loss of GDP. Developed country like USA, it is 2.5% of this the GDP loss. In India, it is what you said. It is more or less same. So in that case, with this new technology, it is something like story like electric car versus petrol car. So the technology wise, it is good, but for the limited application, this is good. But the production cost, so in the steel plants, they are basic business for the volume of productions because the requirement. So I don't think in it is coming next few years the carbon nanotubes will be efficient commodity or material for corrosion mitigation process. But the conventional methods are cheaper in terms of various type of coating, metal coating or organic or inorganic coatings. So that will still dominate. So there are a lot of research and the cost part has to be taken care.
Yeah. Okay, so thank you for this informative session, sir. Can you please repeat difference between rust and corrosion once again?
Yeah, rust is basically in the steel surface, and the steel is coming out from mill, and after descaling, you will find it looks very shining. Now the shining surface, the steel has got at the top layer in the microstructures I showed you, they are very fine, grains, and the grains there are in between grains there are we call it the grain boundaries. And now with the when the moistures availability to the moistures, that means the water H2O or the presence of oxygen, when it touches on the steel surfaces, you get a composition we called Fe2O3, the oxides of iron, and these are Fe3O4. So these are the material. It looks brownish in color, but this is a very light adhering on the steel surface. If you touch, it will come to your finger, the very powder form. Now, if the intensity of this activity is a higher rate, that means the continuously the surface is exposed with the rust, and the new surface is again exposed, and then you get a pitting forms from the defects areas, and then it is called the corrosion. That corrosion cannot be removed. So that becomes a part and parcel of the steel surface. You cannot take it out. That's what we need to have blasting of that. That means that are the fine particles or the pitting marks has to be removed thoroughly so that no traces of electrolyte lying on the steel surfaces. Then we go for various type of coating like primer coating followed by intermediate and then top coat. So I think I have make you understand what is the rust. Rust is a very thin layer which is not allowing steel further to corrode or rusting or like this. But in case of the corrosion, there is a presence of electrolyte in the higher quantity, and you get a new surface every time, and thereby the Fe2O3 or Fe3O4, the layers is further building up. So in the rust, the volume remains same, but the corrosion, the moment the corrosion is there, the volume becomes more. That's what in our building, when you see the rebar is from the from the floor, you can see the roof's rebar. What is the mechanism? Because of the corrosion, it has given up that concrete because the structures is exerting pressure because the rebar volume has increased. If earlier it was suppose a 10 millimeter, it has become 10 points plus something. So that much, and concrete, it cannot take tensile loading. That's what it exerts pressure, and the concrete is falling off.
if for a project construction is held up for, let's say, for almost a year of time, and the stage when work resumes, a majority of the rebars might get corroded, or let's say rusted. So any treatment is recommended, or or it needs to be rejected.
Yes, rejection. That is first thing. We should not go for the rejection. It depends on the severity of corrosion. Now, I'm not talking about rusting. If it is a rusting, it is accepted. It is good for the RCC structure for the bonding purpose. But if it is a corroded, then you have to see at what extent it is corroded. Now there are two issues in the rebar. The body can be corroded and the ribs can be corroded. If the ribs are rib corrosion is more dangerous because that is the area the energy levels are different. So they are in the small area. If you find the more pitting marks, that means that portion has to be very thoroughly cleaned or blasted, and then only you can use after applying some coating. And this normally these coatings are available in the market, rust preventing coating. You have to go for that type of coating, or maybe the slurry. You can apply very thick slurry, keep it for some time, get it dried, and then normally we used to do that. When you have a one-story building, you keep that reinforcement bar exposed to outside, and you apply the cement slurry on the top of that so that it will not be rusted. So that type of treatment you have to go. Or in the market there are rust preventing various type of coatings are available.
Epoxy coating requirement for reinforcement.
See, in epoxy coating, see, epoxy as a coating material, it is one of the best material. When you are seeing all these very high durable structures, normally people are going for epoxy coating as a primer, and then MIO at the intermediate layer, and the top you can go for polyurethane or polysiloxane. But when you are using epoxy for the reinforcement bar, because that a normal steel structure, it is a static structures. Now think about epoxy coating on the reinforcement bar in a plant, because normally there will be plant attached to the site. So they apply the epoxy coating on the reinforcement bar, including various type of bends you have provided, maybe the stirrups also. Up to that stage, it is fine. Now, when it is going in for the construction, making various type of reinforcements, you are just tying up reinforcement bars, handling it, putting it there. Now, in between, if there is any portion, the epoxy is out from that portion, that becomes a dangerous, because that from that point in a concrete solutions you will find epoxy is giving very strong defense against corrosion, but the portion where epoxy is out, that is a vulnerable point. From that point the corrosion will be seep in very fast rate. So there are a lot of reports available. You can search in the internet. Federal Highway of USA, they stopped, they rather banned epoxy coating for many years, and then they might have taken some precautions, and again they have started. But India, we do not have that type of regulations. There is a code for that. People are using it, but in my personal opinion, if someone asks me, I'll go for alternate because of the hazards during the handling, because that you cannot get rid of, because it is in the hands of the people who are not much knowing about the subjects and its consequences. So they
So
are
are
laying
there
that.
any so are there any advantage of CRS steel over epoxy coated steel? That was the next question.
Yeah, CRS actually this is a trade name for Tata Steel, corrosion resistant steel. So it is other name is basically CRS is corrosion resistant steel. All other companies they also make, like Sale is making Sale corrosion resistant steel, HTMT. So this is basically uh, normally copper and phosphorus are added, which provides a small layer on the top of the steel surfaces, and that may give a defense for a certain period of time. But if you think about a ideal situation of epoxy coated steel versus CRS, yes, epoxy will win over the CRS, but only thing you have to again find out the issues of handling issues.
Okay. Okay. Any quick thoughts about FRP rebar application and status in India?
Yeah, already I mentioned that
Already. Yes.
Delhi Metro, I get to
Yes.
know there's a company called Dextra Group.
Hmm.
They are they brought this item in India.
Hmm. Yeah. Okay. Tell us recent trends in glass fiber reinforcement.
Is I don't have much
Yeah.
idea about that
Hmm.
what this enforcement. Only that Dextra is doing. Those who
Hmm.
are interested, kindly search in that website, Dextra
Hmm.
Group, so you
Hmm.
will get that information.
Hmm. Okay, I think we have already answered this question. Use of epoxy coated bar in construction activity as compared to conventional reinforcement without coating. Effect on bonding with concrete. So he's talking about bonding with concrete if let's say epoxy coating is used.
See, as per the codal provision, the bonding is qualifying. Now, issue is I have gone through some of the reports with this in comparison with the normal reinforcement bar. The code only talks about the minimum pass mark. It is something like that. The exam is maximum a student can score 100, but if you score 67%, you get a first class. So it is like that. So in the conventional reinforcement bar with the proper design, you get higher bond strength because the moment you are giving epoxy, so it qualifies that case. But only thing again, it has to depend on so many other parameters, like concrete mixtures and all. But it qualifies. Otherwise, that should not
Right.
have any code.
Okay, so we have already reached to 1.5 hours of time. Yeah. Okay. Okay, so still there are few questions we could see in the chat box, and also I think there are a few questions which we shortlisted, uh, but since we already reached to 1.5 hours of time, so let's plan maybe in the future or again with a very specific topic we may announce, and then we can collect this kind of a questions, and then we can have a more detailed discussion, right? Because it's a very elaborative subject, right? When we talk about metallurgical part of reinforcement and steel structures. Okay. Okay. So thanks a lot, Dr. Jayanta Kumar Saha, for giving your insight related to this very important subject. And you have touched upon very important topics as well as few topics which is generally not being discussed in the practice. Yeah. Okay. Okay, and thank you all for raising many important questions. So still we could see the questions are coming up. Okay, and we could see that there is a nice feedback which is coming up from the participants. So thanks. So thank you all for being online and raising very important points. Thank you, Ashok. Okay, thank you, Sefali. Okay, so with this we are closing this session, and we are signing off now. Okay, so thanks a lot, Dr. Jayanta Kumar sir. Yeah,
Okay, nice.
yeah, yeah.
Thank you very
Thanks.
much for
Yes, thank you.
open sharing.
Yeah, yes, yeah, and sure, definitely we will be having more interesting discussion on a focused topic in a near
Yeah, there
future.
may be the corrosion issues. A lot of issues are
Yeah,
there.
yeah,
Corrosion and then fireproofing.
yeah.
So these are the
Corrosion as
areas.
well as welding. So before we close, if you can
Welding
give
also,
your
yeah.
quick thoughts related to welding. So that was one question. Like let's say if somebody is on site and then if they want to cross check the welding quality, so are there any quick tips from your side, like how they can check whether the welding is done properly or not?
See, for the quick welding checking, there are some of the shortcut methods. First thing is it is on in your naked eyes only you have to check.
Mm.
So that unless otherwise you are a man from that field,
Mm.
you need to know little bit about the welding. I'm not talking about welding metallurgy, but at least the appearance wise, in terms of see that weld bit how it looks.
Mm.
Then the design aspects. If you are a civil engineer, you have to see that yes,
Mm.
the weld properly it is welded or not. Then if there is any pocket type of thing is welded, then you have to see that the vent hole is provided or not. So that is
Yes.
the area again the little corrosion will set in. So all
Mhm.
those things have to, and then the quality of the material they are using it, electrodes and all.
Yes, yes, sure. Thanks a lot. Okay, so we are signing off, and very soon we'll be meeting again with very interesting topic. Okay, so bye from our side. We are closing this session now. Yeah,
Thank you.
yeah, yeah. Most welcome.